Hello, this is Mrs. Huntley. This is Module 4, Linear Relationships. We are in the supplemental packet that has the front cover that says 8th grade curriculum, Linear Relationships. This is a lesson on non-proportional relationships. So what I'd like you to do is open in your packet to the page that looks like this. Add the essential question at the top. How can I tell if an equation, table, or graph is non-proportional? Now we're going to be looking mostly at equations and graphs today. So let's do some fill-in-the-blank notes. A relationship between two quantities is non-proportional if the ratio between the two quantities is not constant. Yesterday we learned about proportional relationships, and in a proportional relationship, when I divide my x by my y, it's going to be the same throughout the entire table. With a non-proportional relationship, it won't be the same throughout the entire table. It doesn't mean that the table is wrong. It just means that the table or the graph is non-proportional. Okay? A graph of a non-proportional relationship will not pass through the origin. Remember, a proportional relationship will. A non-proportional relationship will not pass through the origin. Instead, the graph will cross the y-axis at a point known as the y-intercept. Okay? The y-intercept. It's on the y-axis, so the y makes sense there. Intercept means that's where it's crossing. Okay? So it's crossing the y-axis at a point other than the origin. So what's going to be true about the x value of an ordered pair for the y-intercept? The x value is going to be equal to 0 because that's where when x is 0, whatever y is, it's going to be on the y-axis, okay? So the x value in 0, the x value will be 0 and the y value will be some number. That number is where the line crosses the y-axis. So let's look at a table. Oh, actually, we have a scenario here. In her search for a gym, Hillary found a location that charges $10 as a one-time sign-up fee and $20 each month. Use that information to complete the following. We want to complete a table with the relationship between the number of months at the gym and the total cost of the gym membership. So the total cost of the gym membership is going to be equal to the amount of money that had to be paid as a one-time sign-up fee. So it's one-time sign-up fee. I'm only going to pay that $10 one time, but then I'm going to pay $20 each month. So I need to multiply that 20 times x times number of months plus that $10 fee that we paid. So if x is 0, 20 times 0 is 0, so my cost is going to be 10. Okay, actually I should have put the 20x above that. So let's put it up here. My total cost, which is going to be y, is going to be equal to 20 times the number of months plus 10. And again, that 10 is only paid one time, and that's at the beginning. So 20 times 0 plus 10. What does this mean in the context of the problem? Before I even go into the gym one time, I've got to pay 10 bucks. Okay? At the end of 1 month, or maybe the beginning of the month, depending on when the billing period is, I'm going to pay $20 for the month plus that $10 that I already paid at the beginning. So that's going to be $30. At the end of the second month, my total cost for the gym membership is going to be 20 times 2 or 40 plus 10, which is $50. Go ahead and pause the video and see if you can fill out the rest of the table. Okay. This last one, the 20 times x plus 10, I kind of gave it away at the very top. So our total cost is going to be equal to the monthly charge times the number of months plus the initial cost or the initial value. Now, what is the slope or rate of change shown in the table? Now, I can't just take my y's and divide them by my x. if I do that, I'm not going to get the same thing all the way through. If I do that, I'd get 30 divided by 1, which is 30. 50 divided by 2, that's 25. So it's not, I already know that this is not going to be a proportional relationship. I can't just divide y by x. What I can do is use either the Larkin L or the slope formula to show me something else as far as figuring out the slope or the rate of change. Now, some of you might have an idea of what it is already. And if you do, that's great, but just bear with me, I'm going to prove it. So here I've got my Larkin L. I'm going to use 0 and 10, and then 1 and 30, and I'm going to subtract down. 10 minus 30 is negative 20. 0 minus 1 is negative 1. Negative 20 divided by negative 1 is a positive 20. Okay, so 20 is my slope or my rate of change. It is also the coefficient of x. And if you remember to yesterday's video, we said that the slope is always going to be the coefficient of x. So that might have been the giveaway. What is the y-intercept? The y-intercept is this plus 10 over here. Okay, so 10 is the y-intercept, or it might be called the initial value. The initial value or the y-intercept, wherever x is 0, whatever y is, that is your y-intercept. And the last question says, is the table proportional? Explain. And I already told you the table is not proportional because if I divide my y's by my x's, it's not going to be constant through the whole table. It doesn't mean, again, that this is wrong. It just means that it's not proportional. It also means when I go to graph it, I will not expect there to be a point at 0, 0. My first point is going to be at 0, 10. So here at 0, I'm going to come up and make a dot at 10. Oh, you know what? I just realized that this graph is not labeled the way it should be. So my number of months is going across my x-axis, and my total cost is going up my y, and we'll label or we'll title this graph Hillary's gym membership, or the cost of Hillary's gym, I don't know. Okay, we should label our axes and we should have a title. All right, so I have 0, 10 on here. I've got to do 1 and then 30, 2, all the way up to 50, and 3, up to 70, 4, 90, and that's the end. Use a straight edge. I don't have a straight edge tool, but I'm going to use my line creator thing. And I'm going to draw a straight line from where it begins all the way through my points going all the way up. Okay, this line I can use, like if my graph was longer, I could project my line into the future and say at 10 months, what is the cost? And I can use my graph to tell me that. What is the slope or rate of change shown in the graph? Now again, I can count my slope just like I learned how to do. I'm going to start at 10, that's an integer point here, and I'm going up 10, 20 over 1. So it's going to be 20 over 1. My rise is 20, my run is 1. It's going to be same, consistent throughout the graph. Okay. What is the value of the y-intercept? And again, where is it crossing that y-axis? And that's at 10. Is the graph proportional? Hopefully in your head you're going, no, it is not proportional. Why? Because it does not cross at the origin. Instead, the y-intercept is 10. Now it's a straight line. It's linear. It's just not proportional. This is a non-proportional relationship because there was an initial value. Okay? Write an equation to represent the relationship between x, the number of months at the gym, and y, the total cost of the membership. So I kind of already did this, but in case you didn't catch it, I'm going to do it again. So my total cost is equal to the slope times the number of months at the gym plus the initial value. So we see the slope in the equation, it's 20. It's the coefficient of x. Do you see the y-intercept in the equation? If so, where? It's the plus 10, and that's added or it's sometimes subtracted. It's added to the variable term. What conclusion can we make about a non-proportional relationship? I thought I had this typed out before, but I apparently did not, and I apologize for that. The slope will always be the coefficient of x, and the y-intercept is the value added or subtracted. Now this is if you're in slope-intercept form. This is called slope-intercept form. So sometimes the equation will have to be put in slope-intercept form, which means we'll have to manipulate our numbers, use our addition and subtraction properties of equality to get the y all by itself on one side of the equation. We'll get there. I just wanted to warn you that sometimes the equation is going to be in a different form. So non-proportional equations will be written in the form y equals mx plus b. M is your slope, b is your y-intercept. We use b as to represent the y-intercept. I'm not 100% sure why, but the y and the x, those are your coordinates. So you're going to be plugging in coordinates that make the equation true. M is your slope. Oh, I lost. There we go. M is the slope. Oopsie. Slope, and b, of course, is the y-intercept. We're going to be doing lots of practicing of graphing equations. We've been practicing finding slope a lot, and we're going to be practicing graphing equations and figuring out the equation of a graph a lot. So let's just take a look at some equations and identify the points. All right, what is our slope here? So I look at y equals negative 4x plus 9. What is my coefficient of x? Negative 4. The y-intercept, this thing that gets added on, plus 9. Is it proportional? Nope. Because we're starting, our graph is going to start at positive 9. Okay? Number 2, if you're comfortable, go ahead and pause the video and see if you can identify them on your own. Y equals 3/4 x minus 8. What is the coefficient of x? What is the number being multiplied by x? 3/4. Our b, our y-intercept, minus 8. Is it proportional? No, because we have that minus 8. The next one, again, if you're comfortable, go ahead and pause the video, identify the slope and the y-intercept, state whether you think it's proportional or not, and then unpause the video. Okay, so my slope is being multiplied by x. That's going to be 1.25. Y-intercept is 0. So it's going to be crossing at the origin. Is it proportional? Yes, because my y-intercept is 0. Caroline is going to the state fair with a group of friends. It costs her $12 for admission. And once she is inside the fair, she can buy tickets for $75 or 75 cents each in order to play games, purchase rides, or go on food. Oh my goodness, I'm tired. Play games, purchase food, or go on rides. Write an equation to represent the relationship between the total cost, which they're telling us is y, and the amount of tickets that she buys. And the tickets are going to be x. So y is my total cost. My total cost is going to be equivalent to 75 cents times the number of tickets plus the $12 that it costs her to get in. The slope or rate of change is going to be 0.75. The y-intercept, so whether she buys anything else, it's going to cost her $12. describe what a graph of this relationship would look like. So let's think about it. If I were graphing this on a coordinate plane, my graph is going to start at 0, 12. So my y-intercept is going to be 0, 0, 12. It's going to be a straight line. Straight line graph, and my slope is going to be 3/4, which is 0.75. Hopefully you know that if I've got 75 cents, I've got 3/4 or 3/4 of a dollar. Okay? So that's what the graph would look like. And I know you guys might be confused as far as how I got here. Believe me, it'll make more sense after we're in class and we actually do some practicing on graphing these kinds of equations and determining the equations from a graph, which is what we are planning to do in class the next couple of days. So I hope you enjoyed the video. If you have any questions, please make sure that you're making a note of them so that I can address them in class tomorrow. And notice that there is a summary section, so I do want you to go over this lesson and try to summarize what you've learned. Let's think about it for a second. A non-proportional relationship is going to be in the form y equals mx plus b. There's going to be something added to our variable term. And it's going to, the graph of a non-proportional relationship is going to be a straight line starting someplace on the y-axis and going either up or down, and having the rate of change is going to be the same because it'll be a straight line. It's going to be linear, but it's non-proportional because it does not start at the origin. So again, I will see you in class tomorrow. Have a good night.